Well, how are you doing? Okay, this is going to be a short presentation and it's called Where is the Globe Map? You'll know or you'll recognize at the end why it's called that. This is going to be very explosive to the globe. Very much so. It's a topic I've addressed in the past, but I did address it in this way, but I didn't focus enough on this point. And I realized the point I hadn't focused upon, which was the most destructive point within the topic. Okay, there are 6 points I'm going to cover in this. Number 1 is what is claimed spherical trigonometry. Number 2 is what is spherical excess. Number 3 is how is spherical excess removed. Number 4 is why is spherical excess removed. Number 5, how does spherical excess destroy the globe earth and heliocentric paradigms while outright proving a flat earth. Number 6 is blowing up a balloon. I'll explain the last one at the end. What is claimed spherical trigonometry? Okay, I've addressed this in the past. I showed how when I made a right angle triangle in Google Earth, it didn't matter if I did it over a small distance or a big distance, like over a couple of miles or over the whole of Africa, using the whole of Africa as best I could to make the biggest right angle triangle possible. What would happen is when I compared my right angle triangles in Google Earth to the right angle triangle calculators, the opposites were always equal in length, the adjacents were always equal in length, but the hypotenuse were not equal in length. Now, that not only is mathematically impossible for that to be the case, because you can't have the adjacent and the opposite being the same length and the hypotenuse being less. It has to be a certain length based on trigonometry. So the reason Google Earth were doing this, or do this, is because they're trying to deal with what's known as spherical excess. Even within the realms of what they claim to be spherical trigonometry, you can't shorten what would be the hypotenuse. Once you place that right angle triangle or any triangle onto the surface of a globe, you can't, or a sphere of any kind, you can't change the length of those lines. As in, they must stay the same as they are. They bow out the way, they get warped, but the length of them must stay the same, right? Now, I also showed that surveying companies sometimes will try and claim that there's, and I showed this, less than 180 degrees in an actual triangle. And the reason they're doing that is they're trying to mathematically fit in spherical excess. Once again, incorrectly, right? But Google Earth and surveying companies, etc., they do this and they do it incorrectly because they can't fit it in to reality. I'll go through it now, show you what I mean. Okay, I'm going to start with number 1. What is claimed spherical trigonometry? Right? I'll just show a visual. So here is what they would claim to be a spherical triangle. Now there's no such thing as a spherical triangle, right? It is not triangulometry, it is spherical circleometry. As you can see here on this diagram, there is red dotted lines here matching up to where the black lines are, the black arc lengths are. What that is you have three circles that are all of equal radii and equal radius to the sphere that they are on the outside of. Where they intersect with each other, right, creates this here, which looks like I know it looks like a triangle, but it's not a triangle because it has curved lines and more than 180 degrees. So how did they go about dealing with this issue, right? How did they create these, right? So this is I'm going to link this in the description. This is a spherical trigonometry, Rob Johnson, West Hills Institute of Mathematics. I'm not going to go through every part of this, just going to go through, and I'm not going through all the maths here, because some of the maths I'd have to make sure I'm doing correct. But You won't need all the maths. You'll just need the understanding. The sides of a spherical triangle are arcs of great circles, as I just showed a minute ago. A great circle is the intersection of a sphere with a central plane, a plane through the center of that sphere. The angles of a spherical triangle are measured in the plane tangent to the sphere at the intersection of the sides forming the angle. To avoid conflict with the antipodal triangle, the triangle formed by the same great circles on the opposite side of the sphere, the sides of a spherical triangle will be restricted between 0 and pi radians. The angles will also be restricted between 0 and pi radians so that they remain interior. To derive the basic formulas pertaining to a spherical triangle, we use plane trigonometry on planes related to the spherical triangle. For example, planes tangent to the sphere at one of the vertices of the triangle and central planes containing one side of the triangle. Unless specified otherwise, when projecting onto a plane tangent to the sphere, the projection will be from the center of the sphere, since each side of a spherical triangle is contained in a central plane. The projection of each side onto a tangent plane is a line. We will also assume the radius of the sphere is 1, thus the length of an arc of a great circle is its angle. Okay, that's just for explanation purposes here, that he's given it a length of 1. Okay, what he's trying to point out here is, and I just show, right, I just get a line, is all of spherical triangles are all come from planar trigonometry. That's how they're created, right? They're not an actual triangle. They're the intersection of three circles. So when I call them circleometry, when I call it spherical circleometry as opposed to spherical trigonometry, it's far more correct, because you're using, even though it's comical, the name up to a point, it's correct. It is circleometry. That's what it is, because the creation of, I just get another line here, of what they call a spherical triangle all starts and ends with actual trigonometry, right? So what that is that's a plane, right? Let's say the equatorial plane of this sphere, and where the point on the sphere that this line meets, this makes a right angle to the plane, to the equatorial plane. So this would be this arc length here, and you will have two more of those, or maybe just one more of those, it depends on what you're doing, to give you another two arc lengths. But they're all arc lengths of a circle of equal radius to the sphere. Okay, so I'm just going to remove them so I don't keep them there. Just to show that this is correct, I'm just going to show. Here you have this diagram showing that very thing. As you can see, two different, you have a line out from the center here and a line up meeting here, and the same here. And those points won't always be at the same point on the arcs. So this arc here is longer than this one here, and whatever. So you have these three arcs here. That's what you actually have. You have one circle here, which will be a circle, what they call a great circle, right? Which is just a circle with the equal radius of the sphere. And you have another one here, right? So they're formed from the center of the sphere. The interior of the sphere is where these points come from. And then they're just three circles. Circles are created, what they call great circles, are created intersecting those points and intersecting each other. And that creates what they claim to be a spherical triangle. But it's not a triangle, as I said. It's incorrect, improperly labeled. Now, oh, sorry, I meant to get this one. Now, as you can see here, they're also using a tangent here. So that's another way of doing it, where they're using a tangent with the center. So that's another right triangle, and they're gaining the points via that. That's how this man is doing it. But you can do it. The point is that you're always using the center and you're using right triangles and actual trigonometry to gain these points. So you're using trigonometry, but the result is not trigonometry. It's the intersection point of three circles. So if I just come down a bit, now you can see what they're doing here, right? Right, these are two tangents, right, and another thing being connected by a line between them, which allows for the creation of this inside, right, as you can see. And I just show here, right, that's what it is, two tangents, and that's how they measure the angles, because they can't measure angles with curved lines. They have to use straight lines to measure angles. You can't have an angle between two curved lines. So when they call this one here 88 degrees, it's 88 degrees based off of the tangents and the angle between them, not the angle between the curved lines. They have to shadow them with tangents to get the angle. So like that alone should tell you that there is no such thing as a spherical triangle. It's incorrectly labeled. But look, it is what it is. They label it incorrectly, but it's not a triangle, because when they link up B and C here, so A, B, and C are linked up, you'll have three arc lengths that are intersecting each other. That's not a triangle, and there'll be more than 180 degrees. So that's not a triangle. So just to come down a bit, I'm just going to show you, right, some of the, let me see. Sorry, not that one. Let's come down a bit more. Which one was I looking for? No, not that one. Sorry, I'm after losing myself on this page. This one. Okay, so you can see here the way you have this circle here, right, which would be the equatorial plane. If that was a globe, it'd be the equatorial plane of a globe. And you have two crossing great circles here. So the equatorial plane of a globe will have a radius of close on 3959 miles of the globe out, and you'll have these two circles here. So that's like three what they call great circles intersecting each other. That's what you end up having. That's what you get. So it's not it's not, as I said, it's not a triangle, but that's what is created from the use of triangles, right? And they call it improperly call it spherical trigonometry. Now, just to come back here, what is spherical excess? And that's our next protocol. We know now what everyone's fully aware of what spherical claimed trigonometry is, right? Circleometry. So now we need to go on to what is spherical excess, right? So spherical excess is the amount of area and angle that exists greater than a triangle, right? This is the formula for it. E equals A plus B plus C minus 180. What they're talking about there is, if I just show you, I'll just get it here, is here you have what would be, if it was shadowed by tangents, 390-degree angles, right? That means you have 270 degrees, right, within here. So that means there is a greater degrees and greater area here. So spherical excess is the removal of this greater amount, right? So E equals the excess, A plus B plus C equals the angles. So those 390-degree angles I just showed you, right, they would be, you'd add them up, which I'll show in a while, and right, minus 180 is the amount of degrees in an actual triangle. So the excess is the adding up of the three angles that make up the spherical triangle, and then you minus 180 degrees from that, and whatever is left is the excess, right, basically. So if I just go here, let's just say you had one of these was 68, the other one was, let's just say, 72, and the other one was, I don't know, 81, right? Now that's going to be greater than 180 degrees. So when you minus that 180, we add them up, and that minus 180 degrees from it, you end up with your excess. The excess is the amount of degrees an area that exists within the confines of these three arc lengths, right? So basically, you must turn these back into an actual triangle. That's what it is, right? So that is the formula for spherical excess. So now we go on to why is spherical excess removed, right? How was spherical excess removed? We just showed, right, what they do, how the formula works. Why is spherical excess removed? They remove it because they want to end up back at a triangle again, right? Why do they want to do that? This is the thing, right? They have to do it, right? Now, mathematically, right, it's just, if you're just talking about like just purely mathematically, you can remove the spherical excess and ends up with from your claimed spherical triangle and end up with just an actual triangle, right? Purely mathematically. But when it comes to the globe, Earth, and all the claims concerning that, right, why is spherical excess removed? And this is the thing, right? This works in with number 5, as how does spherical excess destroy the globe Earth and heliocentric paradigms while outright proving a flat Earth? I've gone through this in the past in other videos, and I've said this publicly on different shows and Discord servers in different places many times, that surveyors measure, right, between, let's say, 3 mountains or whatever, or a chain of mountains, they measure using actual triangles, right? And then, right, they add in the globe after the measurements. And when they want to use the measurements, they remove the spherical excess to use the measurements, right? We're getting close to the crescendo here. I've detailed this in the past. My mother's partner is a retired geodetic surveyor. I went through this at length with him about what he does, about what he used to do, and everything he did as far as detailing anything for mapping or anything else or any measurements were all done using actual trigonometry on 180 degrees. Now, afterwards, they can add in globe, right, mathematically, but afterwards they can add that in, but to then use the measurements, they must remove the globe to use them, right, for the creation of maps or to refer to something, a distance, an area, whatever. They need to remove it. And this is where the globe dies. And I'm going to show you how. So I'm just going to show you something. A spherical circulometry triangle with internal angles of 90 plus 90 plus 90, right, which is, let's say, this one here, which is the maximum that a spherical triangle can have, right? And a radius close to 3,959 miles with arc lengths of 6,214.32 miles will have a total internal sum area of over 24 million square miles. If spherical excess is removed to revert back to an actual triangle, then the internal angles must become 60 plus 60 plus 60, as our excess is 90 degrees, because our 90 plus 90 plus 90 equals 270, minus 180 equals 90, right? And the arc lengths become straight lines of 6,214.32 miles in length, giving the triangle a total internal sum area of over 16 million square miles, right? Which leaves us with a differential in area between the two of over 7,800,000 square miles. What this means is, sorry, if you can hear from my voice, I'm trying to get over a chest infection. What this means is, to bring it back to reality, you've got to remove the spherical excess, right? And that means within this example, you're removing almost from your mathematically removing, not in real world, but mathematically, you're removing almost 8 million square miles, right? Now, how we can even have square miles, right, on a sphere is another problem. So they've got to flatten out the whole thing and then remove, they've got to even flatten it out to bring it back to being flat, right? Because there's no such thing as square miles. There can be no such thing as a square mile on a sphere, right? On a globe Earth, right? The reason you can't, or any square can never be a square on the surface of any sphere, because it's going to have greater than 270 degrees internally, right? Because it's, or sorry, not 270, but it'll have 490s if it's a square, and it'll have more than 490s if that square is put onto it'll have 360 inside, because it'll have more than 360, sorry, inside internally, because just like the triangle, the lines will be bowed out the way, right? It always increases the area and increases the internal angles. So you couldn't even have square miles. So it's ridiculous to even talk about there being over 24 million square miles, right, within this claimed spherical triangle. It's ridiculous, right? But that's mathematically how it must be done. So the truth is that there isn't 7,800,000 square miles removed, right? Is that they were never there. The truth is that there was always within that triangle with those three side lengths, there was always only just over 16 million square miles, right? So to bring it from globe to reality, you must remove the excess degrees and the excess area. Now that is bad enough as it is, right? But there's actually more than that to this, and because I've pointed out that in the past, but there's a second part that's actually worse for them, that involves this. What it means, you see, is this. It means that if, right, they have to remove spherical excess to bring back to reality actual real world measurements and real world area, it means that at no point, right, was there ever anyone, and can there be ever anyone, actually measuring a globe Earth. And the reason being is we have such a thing as maps. You can't have a map that has had an area removed from it. So we can measure the Earth as a flat plane, right? A plane with topography above and below, right? That plane. We can measure the Earth horizontally and vertically. We can do that. We can then add an R value and mess around with it and somehow place this Earth on the surface of a sphere and manipulate the bearings via manipulate the bearings with things like magnetic declination, and by manipulating time zones, you're manipulating the positions of places in relation to each other, blah, blah, blah. You can do all that, but the point is you must measure the Earth. None of that can happen without the Earth starting off with and being measured as horizontally and vertically. Flat. There is no way for it to happen the other way around. You can't measure the Earth to be a globe and then take those measurements and place them on a map. What I'm actually saying here, if you haven't caught on yet, is maps could not exist as they do and us use them as they do if the Earth was a globe. The reason being is this is Australia on the globe, right? This is Australia on a map. Now, regardless of the messing around with the longitude lines here and different things like that, the point being is this: on a map, right, if we forget all about the outside area here, just Australia itself, on a map, from Perth to Darwin, Darwin to Sydney, and Sydney back to Perth, you can create a triangle. And with the lengths of those sides, right, you can be sure that the internal area there is actually there. If Australia was on a map, was on a globe, right, and the rest of the world was a globe, then you would not be able to place Australia on a map and then measure, right, using a triangle here, and have the internal area be correct for reality. Because the internal area, if you take that triangle here and place it here, the internal area will be a bit greater, and the angles, right, won't add up to 180 degrees, they'll be greater, right? So if that was the case, there'd be no way to place that on a map without having the use of a lot of extra mathematics just to determine where you're going and what you're doing and the distances. Because you'd have to be able to mathematically remove at all times spherical excess. So you couldn't have a map like this and draw a big triangle on it like this with all those distances in straight lines and have the internal area be correct with reality. That would be impossible. But it wouldn't be impossible if the earth is flat. Then it would be absolutely possible, just like it is in reality. The area that they need to remove only brings it back to reality, because they can't have a map. They can mess around with reality, mess with the time zones, mess with come up with magnetic declination to confuse everybody and everything, right? They can do all those things, but what they can't do is they can't add extra area to Australia or anywhere else that doesn't exist, right? They can't do that. They must remove all that extra nonsense area to actually place Australia on a map. They have to go back to reality. So they can say what they want about the position of Australia in relation to China and this place in relation to that place, and they can mess around, as I said, with time zones and magnetic declination for bearings, and mess around with people and do all that nonsense they want to do. But what they can't do is add extra area that isn't there to the land masses. They can't do that. They can mess around with the seas, add and take away area as they need it, but they can't do it with the land masses. So there's no way for Australia, for me to be able to draw this triangle on Australia, there'll be no way for me to do that without having to take into account that there's missing area in between it if we were actually on a globe. But nobody in history has ever had to do that with any map of topography, of actual, physical topography of land. Nobody has ever had to do that. Nobody has ever had to worry about the area that isn't there, because the area is always there. If I was to do the mathematics, and I was going to do them for this, but I didn't want to confuse matters too much, it doesn't matter. If I was to do the mathematics for this triangle, I guarantee you the exact amount of area that I come up with in the middle of that triangle will be there in reality. Because it doesn't matter if I do it in the big scale or the small scale, that exact amount of area is there. But if we lived on a globe and Australia was on a globe, then the amount of area that's within these three straight lines would not match reality. So, where is your map, globe believers? Where is your map? You've hijacked a flat earth for hundreds of years, and you've gotten away with it now. 300 years. You've been getting away with it. And we've been asked on our side, where is your map, flat earthers, for years and years and years and years. Ye are using it. Every single time you reference any landmass, you're using a flat earth. You're using a map that's based off the Earth being flat, because it can't be based any other way, because the measurements for this were all horizontal and vertical. So when you're using a map, you're using all those horizontals, unless there's a topography map where we'll have some elevations on it. But other than that, you're addressing and dealing with Australia horizontally. So there's no way for truckers, and whether it be Australia, America, Africa, China, Russia, any landmass you want to come up with, there's no way for trains and truckers and people driving to be using a map, whether it be digital or paper map like in the past, and there'll be missing area on the map. There'd be no way to do that. That is, like, there's no way for me to be able to make a triangle and have the area inside it match reality, unless reality is that Australia is flat. Because all the land masses are flat because the Earth is flat. There's no way for that to happen. It's impossible. So you can, right, measure the Earth horizontally and vertically, and then you can convert mathematically to spherical. You can mess around with time zones, you can mess around with magnetic declination, you can do all this nonsense, but when you need that map, you got to come back to reality for the land masses, right? When you need that map, you have to come back to reality, and that means removing globe, right? This must be removed to bring it back to this, which is reality. So you can go from flat mathematically to globe, right? Because the Earth is flat. The measurements are all based off a flat plane. They're all flat Earth measurements, right? All measurements of the Earth are flat Earth measurements, all of them, right? You can do that, and you can measure the Earth, right, as what it is, which is a huge plane with topography, right? And mathematically convert the sphere. And then when you want to use those measurements, like on a map, you can mathematically, remove the excess, the spherical excess, or whatever you want to do to bring it back, right, to the actual measurements. But what you can't do is measure the Earth as a globe and then mathematically put somewhere like Australia on a flat map, right? Because you can't do that and have the internal area here be equal. That can't happen. Because remember, these lines here, these straight lines here, they were all arc lengths. So if I put them here, they would be arc lengths, right? They have to be the same length. So the distance between, let's just say, Darwin and Perth, right? The flight distance, the flight distance has to be equal, right? Mathematically, has to be that arc length can't be any more than what that straight line distance is in reality, right? The same from Perth to Sydney or from Sydney to Darwin. Those distances must be equal. They can't extend those distances, right? But they can increase the internal area, right? Because, well, they don't. Not that they can. They have no choice, because what they have to do is turn these from straight lines into arc lengths, right? Which increases the internal degrees and increases the internal area. But they have to keep those distances the same, right? So they can tell themselves they're flying great circle routes, which would be impossible. But they're not. They're flying straight lines. Because if they're flying and using maps, which they do, over terrain, which they do, right? Then, or driving or anything, there's no way for us to use maps as we do and the Earth be a globe. It's just be impossible. We'd always have to have extra mathematics to go along with the map. But they don't. They never have that, because we don't need it, because the Earth is not a globe. This area in between these straight lines is the area that actually exists. The extra area, the spherical excess, is the mathematical area that's created by the fact that they are mathematically converting from actual measurements to a sphere. That's not measured. So you can go flat to sphere, but you can't go sphere back to flat, which is why maps, the existence of maps at all, absolutely proves that the Earth is flat and not a globe. And just so everyone is aware, one second now. Number 6 here, blowing up a balloon. You take a balloon, before you blow it up, get a marker, draw a little triangle on it. Then slightly blow it up. You will see, don't blow it up too much because you don't want to extend the lengths of the sides of the triangle. Just blow it up slightly and you will see that internally, right, that area has to increase. Right. Now, if you keep blowing it up, obviously the side lengths are going to increase as well, because it can't not. But if you blow it up just enough, you'll see that internal area has to expand. So it's increased. Its overall internal area has increased. Technically, it has increased. You're stretching everything, right? Creating area that wasn't there before you blew it up. Now, if you take that, how are you going to make that flat again if in reality the Earth is a globe? How can you then place those land masses onto a map and just read the map without giving a second thought? You can't do that. You can only do what we do if the Earth is flat. That's it. Maps cannot exist if the Earth's a globe. It's that simple. They just couldn't exist. Be no way for them. Not with how we use them. You'd have to have a load of extra mathematics to be using them at all. And I don't even know if it would be possible for that to happen, because you would have to be like in school. People would have to be learning in high school how to read maps, but how to remove or to add in the area that's missing from the map. Alice Springs here wouldn't be here. Alice Springs in the middle of this triangle here. That wouldn't be there. You'd have to add back in Alice Springs, because that would have been there if you're on a globe. But once the globe went away and you put it onto a map, they'd lose that area. It'd be that ridiculous. But no, in reality, it is just there on the flat map, because maps only exist because the Earth is flat. So when they tell you, the ballers, our opposition, they say, there's always discrepancies between a globe and a map. That's why there's no correct word maps, blah, blah, blah. No, it's not that. It's that because you keep on adding in globe. That's the only reason there's no correct word maps. But the land masses are correct. They have to be. Which proves the Earth is flat. Without a doubt, no way out. Earth is not a globe, but flat. Because if it was a globe, maps, as we know, wouldn't exist. Anyway, that's the end of that. I hope it wasn't too long, and I hope everyone listening to this understands just how devastating this is for our opposition. There's many factors to this. I haven't added in here. Many facets that will become maybe more prevalent in maybe the not so distant future. But at the moment, all anyone needs to know is that maps are flat because the Earth is flat. Because you can't have a globe map. End of story. Thank you.